Welcome dear students, Dr. Hadi here. Today's topic is from biochemistry, that is importance of phospholipids. Dear students, we have already discussed different types of lipids and then different types and structure of phospholipids in my previous lectures. Today a short video lecture will be there, that is the importance of phospholipids. Phospholipids have these following importance that I have mentioned on the whiteboard, and I will explain these points one by one. The very first point is membrane structure. As we know that our cell consists of a double membrane called as the cell membrane, as a double membrane, bilayer. We also call it bilayer. So these bilayer actually consist of phospholipids. You will see phospholipids molecules, these like this one circle represent one phospholipid and two phospholipid. So one layer of the membrane consists of phospholipid molecules, another layer also consists of phospholipid molecules. The phospholipids are actually given a shortcut shape up like this. One is straight and second one is a bent structure. This one stands for the head region. The head region shows us that this contains phosphate group, and because of the phosphate group it is polar side. This is polar side, while these two lines, one straight, one a little bit bent, shows us that this is actually a fatty acid side chain. So one of the fatty acid is saturated and the second fatty acid is unsaturated, and we know very well that phospholipid consists of phosphate group. So this is the shortcut form of a phospholipid molecule, and you will find so many phospholipid molecules arranged in two layers. So this is one phospholipid and this is another phospholipid, and so on. You can write it and so on. Here all you will find such kind of a map around the cell, and we say the cell membrane consists of phospholipids or lipid bilayer. So the credit goes to phospholipid because phospholipid is the integral component of the cell membrane. And what phospholipid do here? What is the function of phospholipid? Phospholipid control the entry and exit, means the permeability of the cell membrane. The permeability. Some substances can pass the cell, can come inside, and they can go outside, but there are some substances which our cell membrane cannot allow to come in or to go out. So the whole credit goes to that cell membrane. Okay, one thing more, that in the cell membrane, very specifically with very special style, these phospholipid molecules are arranged. If you see here, this is inside of the cell, you will see inside of the cell, and this is outside. If you see here the phospholipid head region, this one, the head region, the polar side, facing inside of the cell and outside the cell, because you will find water. You will find water inside the cell and you will also find water outside the cell. Water is a polar compound, polar molecule, so water will interact with phospholipid, and that is so interesting. Phospholipid is not soluble in water, they have no affinity with water, but because of the phosphate group in the lipid, phosphate group makes the lipid polar. Polar lipid, the phospholipid is both polar as well as non-polar, means both part, you will find both these parts, but the polar part is always facing the aqueous side, and here if you see the phosphate groups is facing the outside, means water, because they have a great affinity with water, and in between the two phospholipid heads you will see there are tails of the phospholipids, and the tail is absolutely hydrocarbon, and hydrocarbon have no affinity with water, so they are facing each other here. So that is very special thing to know, that how the cell membrane is organized, in what style the cell membrane is being constructed. So the whole credit goes to the phospholipids. And the second one is the electron transport chain. For this we should come to the mitochondria. Here is the mitochondria, and we know very well that mitochondria consists of two membranes. This is the first outer membrane, and the one which is slightly folded, that is called the second membrane, the inner membrane. At this membrane you will find some protein lipid structures that are called as electron transport chain. And here what happened, that we call it electron transport chain, there are some components on this membrane that during glucose breakdown, when glucose is broken down during a metabolic reaction, during respiration, the electrons are derived, the electrons are taken from the glucose in the form of NADH or FADH. These NADH and FADH molecules will give their electrons to these electron transport chain components, because here you will see different types of protein and lipids, a mixture of protein and lipids you will see there, and this is called as electron transport chain. When electron travel through these electron transport chain, then what happened? Energy is released, and from this energy we get ATP. So now the credit again goes to the phospholipid, because some of the phospholipids are also the part of that electron transport chain. We already have discussed that topic about the electron transport chain. You can see my lecture in Urdu as well, especially electron transport chain by Dr. Hadi in Urdu. In English at advanced level, it will be soon recorded, because I am trying my level best to record each and everything. Now the third one is the fats absorption. Fats absorption from the intestine. If you see here, this is suppose this is your intestine. Okay, this is your intestine, and we know very well that the blood vessels are connected with the intestine. Here is your blood vessel, and when you take fats from outside in your diet, the fats will come to your intestine. Definitely, of course, they will be digested, they will be small enough. How these fats molecules enter into your blood vessel? Again, they take the help of phospholipids. If the phospholipids are present, then the fats will come into your blood, otherwise they will not be able to come into your blood. So again, it goes to the phospholipids. The fourth one is the lipotrophic factor. What is mean by this lipotrophic factor? Here is your liver, that is your liver. Okay, that is your liver. Sometimes if fats are accumulated in your liver more than what is required, then this will be a pathological condition, that will be a disease, and we call it fatty liver. We call it fatty liver. So fatty liver must be prevented, and means we should do some measures, we should adopt some changes so that the fats are not accumulated in the liver. So who will help us? That is the phospholipids. Phospholipid will not let the fats to be accumulated in the liver, so there will be no chances of fatty liver. Therefore, phospholipids are also called as lipotrophic. Lipotrophic means they will not let fats to be accumulated inside your liver. Okay, then now the fifth one is eicosanoid synthesis. Okay, I have to write here what is mean by this. There is a phospholipid. Of course, there is a phospholipid. When that phospholipid is hydrolyzed or broken, a fatty acid will be released from it. A fatty acid will be released from it, and that fatty acid will contain 20 carbon. We know very well fatty acid contain 3, 4, 5, 6, 7, 8, 9, 10, up to 20 carbon. The 20 carbon fatty acid is very well famous fatty acid. We call it arachidonic acid. That is called as arachidonic acid. So that fatty acid is 20 carbon, arachidonic acid. This arachidonic acid will give us a special compound called as eicosanoids. So it will give us a family of compounds called eicosanoids. Means it is not a single compound. From this arachidonic acid we will get different compounds. They are collectively called as eicosanoids. And what are the possible, some of the name of these eicosanoids are prostacyclin, prostacyclins. Prostacyclins means there are more prostacyclins. Prostaglandins, and thromboxane. Prostacyclin and prostaglandin, they participate in various kind of inflammatory reactions in our body. Different kind of inflammatory reactions in our body, they are involved there. Prostacyclin, prostaglandin, cell to cell signaling, they are involved. And there is thromboxane, helps in blood clotting. So these three belongs to eicosanoids, and eicosanoid come from arachidonic acid, and arachidonic acid come from the phospholipid. So once again credit goes to the phospholipid. If there is no phospholipid, there will be no eicosanoid. No eicosanoid means no prostaglandin, prostacyclin, thromboxane. So there will be no reaction mechanism of your body that fight with inflammation. Okay, then we will come to the next one, that is reverse cholesterol transport. You know that cholesterol, sometimes we say cholesterol is bad for the body. So phospholipid will not let the cholesterol to be accumulated in your blood. They will take cholesterol from blood back into the intestine. So therefore we call it reverse cholesterol transport. So it decrease actually the cholesterol level. Although cholesterol is beneficial for the body, so no doubt, but excess of cholesterol is bad. Surfactant, this is very special point. Surfactants. What are surfactants? Surfactants refers to those compounds which decrease the surface tension of a liquid. Means it will help the two liquid to merge into one another. If you have two liquids that they cannot merge into one another, you add surfactant and they will merge. For example, if you have a stain on your cloth and you want to wash that stain with water, so the stain is oily and water is polar, so water cannot wash that stain from your cloth. So what you need a third agent, which is called a surfactant. If you add surfactant, because of surfactant, the water will interact with the stain, oily stain, and it will remove the oily stain from your cloth. This was an idea about surfactant. Surfactant is also present in our body. Where the surfactants are present, and what is the name of that surfactant is dipalmethyl phosphatidylcholine. Phosphatidylcholine dipalmethyl phosphatidylcholine. So a little bit lengthy name, but it is a phospholipid again. This dipalmityl phosphatidylcholine is a surfactant. And where it is present inside our lungs. You know very well that in our lungs we have a structure like this, and when you go inside the lung, you will find small tubules, and with these tubules you will find small sac-like structure. Within sac-like structure you will find more small sac-like structure. These are called as alveoli. Small alveoli are there. These are air bubbles actually, and they are covered by a membrane. When you take oxygen, the oxygen will come and it will enter through these small tubules, and it will finally come into that air bubbles called alveoli. If I write the structure of alveoli a little bit large size, let me zoom it. So that is your alveoli when oxygen come here. Inside the alveoli, especially of child, there is a phospholipid present called dipalmityl phosphatidylcholine, and it is a kind of surfactant. Because of this surfactant, the alveoli wall will not collapse, means it will not become like this. It will not become like this, come towards each other, become collapse. This is one and this is another, become collapse, decrease in size. Decrease size, decrease oxygen, less oxygen, so definitely children will suffer some respiratory problem. And if the child has this surfactant, then the size of this bulb will remain expanded and the air will come easily and out. And because you know very well that around the alveoli there is blood. There is blood. So what happened when oxygen come here? That oxygen will leave that alveoli and it will come to your blood. And carbon dioxide will leave the blood, it will enter into the alveoli. So here, this surfactant help the alveoli not to collapse its size, and the alveoli will remain open. Because of this, some children have a decreased level of that surfactant, and they suffer a disease, a respiratory disease, breathing problem called as that disease is called as infant respiratory distress syndrome. So infant I, respiratory R, distress D, S, IRDS. Infant mean kids, children, respiratory distress syndrome. This is a disease that some children suffer because they have less surfactant. And then one thing more, we can judge, we can analyze the health of the lungs of the child. We can analyze whether the lungs is completely matured or not. So there is a good indicator. What is the indicator? That is LS ratio. What is L? L stand for lecithin, L stand for lecithin, and S stand for that is sphingomyelin. Sphingomyelins. Lecithin is a phospholipid and sphingomyelin is also a phospholipid. So what happened when the child is at 7th month period inside the mother's womb, 7th because the child has to stay there for 9 months. So at 7th month or 28th week, the child start synthesizing that L, lecithin, increase lecithin and decrease sphingomyelin. When increased lecithin is there and decreased sphingomyelin, because of this you will get a bigger number above the line and small number below the line, big number above the line. Whenever when you divide the big number with small number, you will get answer more than 1. So if that the ratio of these two is 2 or more than 2, we say that the lung is healthy. The lung is healthy. Okay, fine. There will be no chance for the IRDS disease. And if in children that ratio is less than 2, there is a problem. There is a chance that the child will suffer that disease, IRDS. So if the child is expected to suffer this disease, he or she is given the natural surfactants or the artificial ones. So that was very, very special way I got with the surfactant. The eighth one is the cephalin in blood clotting. Cephalin is also a phospholipid, and I have already discussed the structure of cephalin under the lecture fatty acid phospholipid structure and types. You can just type phospholipid structure and types and you will get that lecture. So it helps in blood clotting. The last one is secondary messengers. Secondary messengers, as you know, that we have some in hormones. There are some hormones in our body, and whenever these hormones perform its action, what they do, they will come to our cell. And when they come to our cell, our cell contain receptor. There is a receptor on our cell. So when the hormone attaches to that receptor, whether the receptor is around the cell or it is inside the cell, it's okay. But when the hormone attached with the receptor, what happens? The receptor makes a special molecule called secondary messenger, and that is phosphatidyl inositol. Phosphatidyl inositol. This is a phospholipid already present there with the cell membrane, with our cell membrane, phosphatidyl inositol. When the receptor is activated, means when the hormone is attached with the receptor, that phosphatidyl inositol will break up. It will give us inositol triphosphate. Inositol triphosphate. Inositol triphosphate. How we call it IP3. For the pharmacology point of view, the students know very well that IP3 is a very well known secondary messenger. Inositol triphosphate. That inositol triphosphate will break down into two parts. One is diacylglycerol. We write it DAG, diacylglycerol. This is a very well known secondary messenger, and inositol. These two are very well known secondary messengers, and because of these two secondary messenger, hormones will perform their action. That is inositol triphosphate. This is inositol triphosphate. Okay, and these two will come from the phosphatidyl inositol that is present. So the diacylglycerol and inositol triphosphate, IP3, these two are very well known secondary messengers, and if these two are absent, hormones will not perform. If you want hormones to perform the action, they must release these two secondary messenger from the phosphatidyl inositol which is present. So I hope you got that lecture of phospholipid importance. If not, repeat it again and again. You will get that, inshallah. Thank you. Take care. Allah Hafiz.